Welcome to this explainer. Today, we're looking at what you might call the invisible architecture of our modern world. We usually focus on the sleek designs of our gadgets or the amazing software running our lives, but we rarely stop to think about the physical, raw materials that actually make all of this possible. So, in this quick explainer, we're going to unpack the critical minerals that are quite literally driving the future of global technology.
Okay, let's dive right in. I want you to think for a second about the device you're probably watching this on right now. Or think about those electric vehicles you see quietly gliding down your street, or even the massive wind turbines generating power out on the horizon. What fundamental components actually make these modern marvels function? We hear a lot about batteries and microchips, right? But beneath those components is a highly specific category of materials that serve as the absolute building blocks for all of them.
Section 1. What are rare earths? The 17 minerals.
To really understand the tech of tomorrow, we have to understand this foundation today. Rare earth elements, or REEs for short, are a specific group of exactly 17 critical minerals. Now here is the most crucial and honestly the most surprising point to understand. Despite being called rare, these elements are not actually rare in the Earth's crust. In fact, some of them are as abundant as copper or lead, and you can find them all across the globe. So why the intense focus on them? Well, the reality is a massive economic and technical challenge. They are incredibly difficult and immensely expensive to mine and process in a way that actually makes financial sense. See, they don't cluster together in easy-to-mine veins like gold or copper. Separating these 17 elements from the surrounding rock and from each other requires some seriously complex, costly, and resource-intensive processing. So they might be rare in name, but they are absolutely priceless in value to our global economy.
Section 2. Critical tech uses. Modern applications.
It's fascinating to see exactly why these 17 elements are considered the backbone of modern society. Let's look at the sheer scope of their use. We start with everyday consumer electronics. Your smartphones and laptops depend on them for everything from their color screens right down to their tiny speakers. But it scales up rapidly from there. As we transition to clean energy, REEs are the secret ingredient. They're critical for the motors in EVs and the generators inside wind turbines, not to mention the advanced batteries storing all that energy. And it doesn't stop at consumer goods or green tech either. These minerals are vital for national security, used heavily in fighter jets and complex defense systems. Plus, as we look ahead, the hardware required to run artificial intelligence, robotics, and high-tech manufacturing leans heavily on these exact same 17 elements. It just brilliantly illustrates that rare earth elements aren't some niche material for one industry. They're the shared foundation of almost every major technological advancement happening on the planet right now.
Section 3. Global supply chain. Centralized processing.
Let's explore how this builds into the geopolitical reality of our world today. Knowing how essential these 17 elements are across all those sectors we just looked at, the next logical question is, where do they actually come from? Currently, the processing and refining of rare earth elements is heavily centralized. China currently dominates this global processing and refining industry. This is just a straightforward macroeconomic fact, and it's an incredibly important one. Because extracting and refining these minerals is so notoriously difficult and expensive, like we established earlier, mastering that process at a massive scale gives a single nation enormous influence over the critical supply chains of the entire world. When one source controls the refinement of the materials needed for literally everything from smartphones to fighter jets, it creates a significant supply chain bottleneck that the rest of the global market must navigate.
Section 4. Domestic capabilities. Diversifying supply.
To understand where the global market is heading next, we need to look at the worldwide response to this bottleneck. Right now, we face a global state of single-source dependence. But in response to that, we are seeing a massive shift in strategy. Because the world is naturally concerned about relying on a single source for materials that power everything from AI to clean energy, we're seeing massive realignments. The United States, members of the G7, and India are now investing heavily to build up their own domestic capacities. India's opportunity here is actually particularly notable, as they already possess significant rare earth resources of their own. They're now actively working to strengthen their domestic mining, processing, and manufacturing capabilities. This is a huge shift. By doing this, these countries aren't just securing their own supply chains, they're looking at creating entirely new industries, generating jobs, and building distinct strategic advantages for the years ahead. It's a highly concerted effort across multiple major global players to diversify exactly where the world gets its most critical materials.
Which brings us to our final thought. For the last century, global geopolitics, economics, and industry were largely defined by the race for energy, specifically the race for oil. But as we look at the rapid transition toward electric vehicles, clean energy, artificial intelligence and advanced robotics, the whole paradigm is shifting. The future of technology may not depend on oil at all, but rather on these 17 little-known minerals hidden beneath the earth. So I leave you with this to consider. As we watch countries pour billions into securing these supply chains, is the next great global race really going to be for traditional energy, or has the true race already begun for the critical materials powering our future? Thank you so much for joining me for this explainer. Keep questioning how the world around you is built, and I'll catch you next time.